In this concept video, we're going to be discussing special right triangles. And you see those two right here. We're talking about the 30, 60, 90 and then the 45, 45, 90. Then we'll take each one of those triangles and we'll put that on the coordinate plane, which is down here. So let's get started with the triangle on the left-hand side. And arbitrarily, I'm going to make each hypotenuse here in each triangle just 1. This will definitely make sense to you when we get to the unit circle. The unit circle is a special circle that has a radius of 1, and it turns out when we put this right triangle on the coordinate plane that the hypotenuse will be the same thing as that radius, so the link will be directly established here when we do that unit circle together. And we'll do that in class. So after you have an idea of these special right triangles and how they apply in the coordinate plane, then in class we'll be able to fill in that wonderful unit circle. To figure out the other values, the other legs on this 30, 60, 90, we need to draw another triangle. This triangle is going to be a reflection of this one, so it's going to be the exact same thing, just flipped. So I'll see how well I do here. Oop. There we go. So that's going to be a right angle. And then we're going to have 60 degrees here. Ooh, that's a different color, but that's okay. And 30 degrees right here. You'll notice that what we've essentially done here is we've created an equilateral triangle. So we've got 60 degrees, and then this whole angle is also 60 degrees. That being said, we could also say that this length from here to here would be the same as this length. It's just another side of an equilateral triangle. And if we're looking at just this length here, which is the one we're concerned with in the original triangle, that's going to be 1/2 of all the way across. We're imagining that this is exactly the same as this segment over here. So we can say that when the hypotenuse is 1, the side opposite the 30-degree angle is 1/2. This other side here is a little bit trickier. Maybe we'll make this b or something like that. The variable really doesn't matter. Whatever you want it to be is fine. And what we'll do is we'll set up the Pythagorean theorem then. So we'll do b squared plus the quantity of 1/2 squared is equal to 1 squared. We can simplify this 1/2 squared. 1/2 times 1/2 is 1/4. 1 squared, of course, is just 1. We could subtract 1/4 from each side, and b squared is equal to 3/4, and then square root the whole thing. So we've got the square root of 3 over the square root of 4, which is just 2. So I'm not sure if you remember that from one of your past math classes. Maybe you were just told that's what it was, or maybe you called this x and this was x over 2 and that was x root 3 over 2, or some combination thereof, or maybe this was 2 and that was 1 and that was root 3. Those relationships still hold true, but it turns out when the hypotenuse is 1 that you can logically and rationally conclude that this side length is 1/2, and then b here is going to be root 3/2. We can try to figure out the other side lengths here with this 45, 45, 90. It's actually a little bit easier. You don't even have to draw another triangle. We do know that sides in a triangle that are opposite of angles that are the same length will be, or sides opposite of angles that are the same size will be the same length. In other words, these legs here is what I'm trying to say, will be congruent. They'll be the same. So if we make these maybe x, if we solve for x, we'll be finding these other two legs. Again, this is a right triangle, so we could use our Pythagorean relationship here, and we've got one leg squared plus the other leg squared equals the hypotenuse squared. So we've got 2x squared here. That's equal to 1. We could divide by 2, and x squared is equal to 1/2. Square rooting each side, we find that x is equal to the square root of 1, which is 1 over root 2. Sometimes it's easier to work with this relationship, 1 over root 2, but oftentimes, and especially like on the unit circle and stuff, you're going to see this being rationalized. So what we need to do is multiply by root 2 over root 2. So we've got 1 times root 2, or root 2 over root 2 times root 2, which is 2. So the value of x here, both of these, those are root 2 over 2. That's where those values come from. Let's back up a little bit and take a look at this 30, 60, 90, and we're going to apply it to the coordinate plane, which is now on the video. And what we can do is we'll take this, let's just do an angle of maybe 30 degrees here. So I'll try to draw the best 30-degree angle I can. There we are, and so this angle would be 30 degrees. And what we're going to do is we're going to make a right triangle out of this. So we're going to drop an altitude right down from this point right here, and then this angle here would be 60 degrees as well. We're saying that this is 1. We can imagine a circle around this coordinate plane with a center right here at the origin. And now we've taken this right triangle, this 30, 60, 90, and then we've put it onto the coordinate plane. Of course, the initial side here stays on the positive x-axis. If we want to know the point or the coordinates of this point, we can look at this distance here. That's the x direction, and then this will be the y direction. If we fill in our knowledge from the previous example here of our leg lengths, we know that the side opposite the 30 is 1/2, and then root 3 over 2 will be the other one, the side opposite of the 60-degree angle. So to get to this point, we would go right by root 3 over 2, and then up by 1/2. And that's where that coordinate comes from on the unit circle. If we had the triangle drawn up here, then the x-coordinate would be 1/2 and the y-coordinate would be root 3 over 2. So you'll find 30 degrees and 60 degrees will have either root 3 over 2 or 1/2, and then any multiple thereof, you'll find that those values will stay consistent as well. If we look at the 45, 45, 90, we can draw that right here. We're going to do the same thing. We'll drop an altitude down, create our right triangle. So we've got 45 degrees here and 45 degrees here. We want to know what the coordinates are of this point. We know this distance is 1. We're arbitrarily making it 1 just because the unit circle has a radius of 1. And so each leg here will be root 2 over 2 and root 2 over 2. If we want to know the coordinate pair, or the coordinate, the ordered pair, that is the location of this point, then all we need to do is figure out how far right to go and then how far up. So in the positive x direction we go root 2 over 2, and then the positive y direction we also go root 2 over 2.